Okay, so now that we introduce you to what logs are, we're going to go ahead and do an application of logs. Again, just to remind you this, because it looks kind of really complicated. Again, I want to remind you, when you see a log, it's asking you a question. So let me invent one more. If I say log base 3 of 27, you have to say, well, what question is being asked? This is asking 3 raised to what number equals 27? So I know the answer is 3 because 3 to the power of 3 is 27. That's what's being asked there. Quick review again. Let's create another one. How about log base? Let's go with log base 5 of 25. Log base 5 of 25. The answer is 2. Okay, just to remind you of what we did with logs and what we have over here. Now let's look at applications here. Earthquakes and amplitudes and the Richter scale are measured using logs here. And so A is the amplitude of a seismic wave. A sub 0 is called the reference amplitude. So if you can measure those, you can find out R, which is the value in the Richter scale. If they say, oh, it's a 5.3, something like that. So we can look at, we're going to use that equation here. And so in this problem, you're given that the amplitude is 2 times 10 to the power of 8 times larger than the reference amplitude. So we know that the A is this much times stronger than the reference one. And so this is all you would plug in. Those A's would cancel, so you're left with this. And then you go ahead and get your calculator out, plug that in, and you get 8.3. 2 times 10 to the 8 gets put in the log. So again, that would just be log 2 times 10 to the power of 8. And you can see you get 8.3, magnitude 8.3. So you can see what I did on that problem there for the computer and the calculator. That's it. Same thing here, 6.31 times 10 to the 6 times larger. You plug that into your calculator and you would get 6.8. So that's how strong that earthquake was. And on this case, the ratio, you just do the ratio of those two, and you can see that the earthquake was 31 times stronger. That's what that would mean in terms of determining how many times greater, 31 times greater. One more application here, looking at measuring of acidity or alkalinity of a solution. Against more of a chemistry situation. And again, we have this equation here. It looks really complicated. pH is a pH level. It's measuring how much the pH of a solution, right, is given by negative log of H plus. H plus is the hydrogen ion concentration. So you're given that value, you can see just substituting that in, and then you would get an answer. So in this one, negative log 6.2 times 10 to the negative 4, negative log, I think it was 6.2. 6.2 times 10 to the negative 4. Let me fix that real quick. Times 10 to the negative 4. There we go. So you see you get 3.2 right there, which is we have here. And then again, based on the situation, we would say it's acidic. And then you just go ahead and plug each of those into the equation. Get a value, and then you can determine if the solution is acidic or alkaline.